Disorder and spontaneity of a process which proceeds of its own according to or under given set of conditions without any outside assistance is called spontaneous reaction. However, there are some processes which require initiation before they can proceed. Such processes, once initiated, proceed by themselves. For example, burning of coal in the air. The coal burns only when a flame is brought near the coal. Examples of spontaneous reactions. 1. Dissolution of sugar or salt in water. Sugar plus water is equal to solution of sugar in water. Salt plus water is equal to solution of salt in water. 2. Neutralization of NaOH by HCl. HCl reacts with NaOH to give NaCl and H2O. The tendency of a process to occur spontaneously is called spontaneity. Driving force in a given set of conditions, a chemical reaction proceeds spontaneously in a particular direction. The occurrence of the same reaction in the same set of conditions is not spontaneous in the opposite direction. Therefore, there must be a driving force which makes a chemical reaction spontaneous in a particular direction. The force which is responsible for the spontaneity of a reaction, that is, the force which makes a reaction spontaneous in a particular direction is called the driving force. Randomness and spontaneity. A spontaneous process is always followed by an increase in the disorder or randomness of the system. This can be understood with the help of following examples. 1. Mixing of two gases. Mixing of two gases is a spontaneous process. Suppose we have two containers A and B connected through a valve C. Suppose container A is filled with helium and container B is filled with argon. When the valve C is opened, the two gases mix up together spontaneously. Mixing of two gases. Before mixing, the two gases were orderly filled in their respective containers. After mixing, the two gases occupy both the containers. Thus, the disorder or randomness has increased as each gas occupies a large volume. Spreading of ink in water. If a drop of ink is added to water contained in a beaker, it spreads spontaneously throughout the water and the whole solution becomes colored. The process involves an increase in the randomness. In the drop of ink molecules were confined to the volume of the drop, that is, they were quite ordered. On adding the drop to water, ink molecules spread throughout the solution and become more disordered. Entropy. Entropy is a measure of degree of disorder or randomness of a system. Entropy was introduced by Clausius in 1850. It is a state function and is represented by S. According to Process, entropy of a system remains constant if it is not undergoing any physical or chemical change, that is, the system does not involve any exchange of heat. When heat flows into the system, the entropy of the system increases and vice versa. Change in entropy. For a reversible change, the change in entropy is defined as follows. Delta S is equal to Q reversible upon T, where Q reversible is the heat supplied isothermally and reversibly to the system at temperature T. Units of the entropy change are joule per degree or joule per Kelvin. Second law of thermodynamics. A spontaneous process is irreversible and involves an increase in the disorder of the system. It always tends towards equilibrium. If one intends to go against a spontaneous process, one must have to do some effort and spend some energy in some form. This forms the basis of second law of thermodynamics. It states that it is impossible to convert energy completely into equivalent amount of work without producing changes elsewhere. Entropy changes. Entropy is a state function, therefore, changes in entropy depends only upon the initial and final state of the system and not upon the path by which the system transmits from the initial state to the final state. Thus, delta S is equal to S final state minus S initial state. And for chemical reactions, delta S is equal to S of products minus S of reactants. The change in entropy, delta S, may be defined as the heat absorbed reversibly by the system divided by the temperature at which the heat is absorbed. The change in entropy, that is, delta S, is an extensive property and depends upon the number of moles of the substance present in the system. It is usually expressed in units of joule per Kelvin per mole or calories per Kelvin per mole. For an isolated system, for spontaneous processes occurring in isolated system, the entropy change of the system is positive. For open and closed systems, such cases involves exchange of matter or energy or both with the surroundings. In such cases, entropy change of both the system and the surroundings are considered. Delta S total is equal to delta S of system plus delta S of surroundings. For spontaneous process, delta S total is greater than zero. The criterion for the spontaneity of a process in terms of entropy can be summarized as follows. 1. Delta S is greater than 0. Implies process is spontaneous in the direction as mentioned. 2. Delta S is equal to 0 implies process is in equilibrium. 3. Delta S is less than 0 implies process is non-spontaneous in the direction as mentioned. Applications of entropy. This can be helpful in calculating the efficiency of thermal power plants.